Hello, I'm Peter Wibberley. I work in the Time Group at MPL, and this is our main timescale laboratory. In this room, we generate the UK's national timescale based on the group of atomic clocks that we have here at MPL. We have a total of 7 clocks here. 4 are what are called hydrogen masers, the other 3 are cesium clocks. The masers are our best clocks, they're the most stable clocks, and so we use the 4 masers as our main reference for keeping time. Well, for many centuries we had Greenwich Mean Time, which was time based on the Earth's rotation. And that was fine up until really the 1950s, when it became clear that the Earth actually isn't a very good timekeeper. It speeds up and slows down unpredictably. And today we have atomic clocks, which are much better at keeping time than the Earth itself. And so we use groups of atomic clocks to maintain timescales. Each major country has its own national timing centre with a group of atomic clocks that provide that country's timescale. But of course time has to be coordinated worldwide. We have a single worldwide timescale called Coordinated Universal Time, and the timescale at MPL feeds into that. Our clocks combine with others to form UTC, Coordinated Universal Time, and they form our national timescale here, which is called UTC NPL. The first atomic clock that became operational, the first really successful one, was actually built here at MPL back in 1955. And that was a clock that was used to compare the cesium frequency, the ticking of the cesium clock, with the Earth's rotation. Measurements were made at the United States Naval Observatory of the rate of the Earth's rotation at that time, and the MPL clock was compared against that to provide a value for the cesium frequency, which later became the definition of the second that we still use today. Atomic clocks are based on transitions within atoms, the very precise frequencies generated by the clocks. And because these frequencies are dependent on the fundamental properties of the atoms, they're always the same. You can build a cesium clock here or at the end of the universe in millions of years' time, and they'll both give the same frequency. They both tick at the same rate. And so they're very stable and very reliable timekeepers. The best clocks we have here, the hydrogen masers, are accurate to much better than a billionth of a second over one day. Well, there are really 2 main applications these days that do need very precise timekeeping. One is telecommunications, where you have networks that are synchronized worldwide, and you have to have atomic clocks at key nodes in these networks to ensure that they interrelate correctly. The other is satellite navigation, where we have atomic clocks on board the satellites themselves, sending out very precisely timed signals. And these signals allow you to work out precisely where you are on the Earth's surface, simply by working out how long it takes for the signal to get from the clock on a satellite down to you on the ground. There's actually very small changes in clocks due to the strength of gravity. The higher a clock up is above the Earth's surface, then the weaker gravity is, and the faster that clock will tick. And so we have to actually correct our clocks to take account of gravity. Well, of course, having the timescale here is fine, but we need to interrelate our clocks with those in other national timing centres to combine them all together into a single world timescale. And to do that, we have time transfer links, which compare our atomic clocks with those in other locations. We have a radio signal called MSF. It's broadcast from up in Cumbria, and this is a time signal, dedicated time signal that covers the whole of the UK and is widely used to synchronise inexpensive radio-controlled clocks to the correct time. And that signal is monitored by us here down in Teddington and is controlled locally at the radio station by atomic clocks. So it's always very precisely aligned to the timescale here. And we also have a couple of services which send time out over the internet or over dial-up connections so that computers can set themselves to the correct time. MPL is now the top-level timing centre for the UK. If people want to know the precise time in the UK, they'll come to us.